Welcome back. In today's video, we will be understanding the concepts of chapter number 16 graphics from Pearson IGCSE ICT. Its code is 4IT102 and 02 indicates that this is part of paper 2, which is the practical chapter and practical unit. In chapter number 16, we will be talking about images, its types, and editing which we can perform on the given graphics. So very quickly we will start with the topics. An image is a visual representation of anything that we can see by the eye or by using a camera. When we are saving the images can be saved in different formats such as JPEG, PNG, GIF and BMP. The types of images are bitmap and vector. The difference between vector and bitmap image is the bitmap image is made up of tiny dots, and those tiny dots are called pixels, whereas the vector images are made up of mathematical equations and formulas, and they are resolution independent. We will be knowing more about the types of images in the later stages of this video. So the bitmap image is an image, as we have just said, that it is made up of tiny squares or tiny dots which are called pixels, and pixel is the smallest element of a bitmap image. It is a building block of a bitmap image. Every pixel in the bitmap image is responsible for storing a unique binary code for the color. So binary code, as you know, the binary is always in the form of zeros and ones. So if I am storing a black pixel, it will be in this form. There are going to be 8 zeros, 1, 2, 3, 4, 5, 6, 7 and 8. So this is the code of black. If I am saving a white color, or if there is a white pixel, it is going to be in this form. So this is the binary code of white. So what we understand from this information, that every pixel has its unique binary code. So if there are more pixels in an image, it means that there will be more information in that image. And when there is more information, there is more code, more binary code. So bigger the binary code, it means the image size is going to be bigger. So for now, we need to know that every pixel contains a unique binary code for its color. A bitmap image, when enlarged, it gets pixelated. So what is the meaning of the word pixelated? When we enlarge the image, it becomes blurry. When we enlarge the image, it does not remain as sharp as when it was reduced size. So why does it become blurry? We will be understanding now. For example, there is an image and it is 500 by 500. So it means that there are 250,000 pixels in that image. When I enlarge, when I scale up to 2000 by 2000, the computer is not going to create new pixels, but the same amount of pixels, which are 250,000, they are going to be covering more area, more blocks. So less amount of pixels are there which are covering bigger area. So the image will become pixelated because there is no production of new pixels. So if we enlarge the image to its twice the size or 4 times of its size, it does not create new pixels at all. Instead, it stretches the existing pixels, which are 250,000, making each pixel larger. This causes the image to become blurry or pixelated. So the number of pixels in the bitmap image remain the same. That is why when we enlarge a bitmap image, it gets pixelated and it loses the quality as well. So the takeaway from this discussion is that a bitmap image has a fixed resolution because it contains the fixed number of pixels in our, as we have discussed in our example, that the number of pixels for this particular example is 250,000. When we enlarge the image, the pixels are stretched rather than there are new pixels being added. So the image becomes pixelated and it will lose the quality. The example of bitmap image is a photograph taken by the camera. Now, if we are having more number of pixels in any image, it will have better quality. Better quality means that it will be more sharper and more brighter and more clear as well. Now, what is a vector image? A vector image is created by mathematical equations and formulas. It is resolution independent because it is not made up of pixels. Instead, it is made up of mathematical formulas that describe lines, curves, and shapes. So it means that if you scale up or scale down, its quality will remain the same. It will not lose the quality at all. Let's take an example of a vector image that we have to draw a circle, and the circle is an example of a vector image. For this image, we only need a certain information, that is the center point, its coordinates x and y. For example, the coordinates, the center is 100 x and 100 y, and the radius is, for instance, 50 pixels, 50 points. Now this is a smaller circle. A circle is going to be created. So how the system is going to read it, that the center is 100 x-axis and 100 y-axis and it's 50 points radius. Now if I want to enlarge it, when I enlarge by keeping the same center, I can give a bigger radius. So when I have given the bigger radius, the computer will recalculate the mathematical formula and redraw a circle with the new size, with the bigger size. But it will not stretch anything. It's not going to make the image or the shape blurry. It's going to redraw the circle by recalculating the values given. So the edges will be perfectly smooth and sharp. There will be no pixelation. It can be enlarged or reduced without losing a quality. So from this discussion, we understand that the vector images are resolution independent. What does it mean? That their resolution, they do not have a fixed resolution, and for this reason they don't lose the quality because they are stored as mathematical formulas rather than the pixels, rather than a fixed number of pixels. When the image is resized, the computer redraws the shape using the formulas or the equation. So the image remains sharp and does not lose the quality. A typical example of a vector image is logos and the computer clip art also. Clip art images, these are also examples of vector images. Let's talk about the difference between Bitmap and vector image. A bitmap is made up of pixels, whereas the vector images are made up of equations and coordinates. The resolution of bitmap image is fixed. The vector images are resolution independent. Bitmap image loses the quality when they scaled up, whereas vector images scales with zero quality loss. Bitmap images are best for the photographs because of giving the realistic information, and vector images are good for logos and clip art. A bitmap image has a larger file size because when there is more detail means there are going to be more pixels, and more pixels mean that there are more binary code, and more binary code means that there is bigger file size. And the vector images are smaller in file size. That's why they are very good for using on the websites, because they are smaller in their size. Now here you can see the example of a bitmap and a vector image. When the S, which is written in black color, it is scaled up, it gets pixelated. You can see that it gets blurry and blocky also, whereas the S, which is written in blue color on the right hand side, it retains its quality because this is a vector image. So vector and the bitmap image, they differ in this way as well, that when they scaled up, bitmap images, they get pixelated, and vector images, they do not get pixelated, they preserve their quality. Now we will be discussing the editing of images. The first form of editing is resizing the picture or the image. The resizing the picture or the image means that changing the dimensions by dragging its corner or edges. You can see that these are the edges. If I am dragging the image from the diagonal handles, these are the diagonal handles. If I am changing the size by dragging it from the diagonal handles, I am preserving, I am not changing the aspect ratio. Now what is aspect ratio? It is the proportion between the height and the width of the image. So when we are dragging by using the diagonal handles, I am not changing the aspect ratio. The height and the width, they are increased or decreased with the same proportion when I am using the diagonal handles. But when I am adjusting the aspect ratio, means I am changing the aspect ratio, I am distorting the image, I am changing the information. You can see now I have distorted the image. So if I am increasing the size by using these handles, then I am distorting the shape. So always try to maintain the aspect ratio, so it will not distort the information, it will not change the image information. So what is our takeaway? That always change by using the diagonal handles when you are scaling it up or when you are scaling it down. Now another editing technique is cropping the image. What is cropping the image? Cropping the image means that you are cutting out the part which you do not need, like discarding the part of the image which you are not in need. So let's try to crop this image. I want to keep only the scissors on the image, and I want to remove all the other stationery. So I'm going to go to the picture format and then pick the crop option and remove the other part and keep only the scissors. So this is called cropping. Cropping means you are cutting out or discarding the part of the image which you don't need. The next form of editing is rotating the image. Rotating means that turning the image around a center point. It is usually in the exam that they say that rotate it 90 degree or 180 degree. When they are saying 90 degree, they do mention right or left. But for 180 degree, they do not usually mention, because if you are rotating right or left, eventually you will be having the same form of image if it is 180. So how do we rotate? Like for example, this is select the image, go to rotate. If it is 90 degree left, select this option, or if it is 90 degree right, you will be selecting the other option. And if it is 180 degree, you are going to rotate 90 degree 2 times in the same direction. So this is how you rotate any picture or image. Flipping the image creates the mirror image either horizontally or vertically. The horizontal means that it is going to create the image from left to right or right to left, or vertically it is going to be from top to bottom. So let's try to rotate this image. Go to rotate and flip vertically. I can flip this vertically like that also. Flip vertically. So we can use the handles also to flip, or we can use the option from the ribbon as well. We can flip it horizontally as well, flip horizontal. So this is how we can flip horizontally by using the handles as well. So you can see like this. Now we will be knowing about grouping and layering of the images. The grouping combines different images so they can be moved or transformed as a single unit. Let's try to group these different rectangles, these shapes. For example, if I am moving one rectangle, it is moving as a part of the 3 rectangles, but I want to move them together. So for that reason, what would I do? I'm going to select all of these rectangles, then I'm going to right click on it and then click on group. Now if I am moving one, the rest are going to be moved together. So they are moving as a single unit. They are now become the part of one unit. I'm going to ungroup it because I want to explain the layering on the same rectangles. So grouping, we know that combining different images and then making it as a single unit. And what is layering? Placing one image on the top of another. So I will delete these and will create new, add new rectangles. For example, this is first, this is second, and this is the third one. To differentiate, we will be changing the colors. All right, now you can see that I have kept one rectangle on another. So when you are placing an image on the top of another image, this is called layering. Now I want to bring the last rectangle at the top of the purple one. So how can we do that? Because I kept it first, so it has gone at the back, but no worries, I can always bring it at front. So you can right click on it and then bring it to front. You can see that it has become, it has come to the front. So we can send it at the back. We can send this one at the back also, the orange one. Right click on it and then send to back. You can see that it has gone at the back. So this is called layering. Layering involves putting the images on top of one another, and we can move them front or send them back as well. So with this, we have discussed all the topics of chapter number 16. This is all that you need to know for the graphics chapter number 16. And now for a quick understanding check, I want you to pause the video for 2 minutes and try to answer these questions. Like, what is a pixel? Give one advantage of vector image over bitmap image. What two values are stored to create the vector circle? Difference between cropping and resizing on image, and explain the difference between grouping and layering. I hope you answered the questions. These are the answers you can check. And with this, we are ending the video. There will be one more short video about the practical questions from the past papers related to the chapter number 16. So in the next video, we will be solving the exam style question from the past paper.